All right, class. So go and get out a sheet of paper for some notes. You can close those Mac books. While you're doing that, let me always direct you back to those back whiteboards. So remember today, your 10 topics are due, as well as the homeworks, Radical Review 1, Radical Review 2, Radical Review 3. Next week, I don't have that listed there, but I'll have that here before the end of the day. As of now, there's going to be at least 2 homework assignments that are going to be due in addition to your 10 topics. And those are Right Triangle Trig 1 and Right Triangle Trig 2. If you look at what we did yesterday, the Right Triangle Trig 1 deals with the special right triangles. We talked about that, and you have until next Friday to complete that homework. And then Right Triangle Trig 2 is today's lesson. So if you look on Alex, you will see, for instance, that the Radical Review 1, 2, and 3 deadline is not until the 8th week of this 9 weeks. Okay, if you're looking at that, so just to repeat this fact, the deadline in Alex is set all the way to week 8 on Friday. That's per school policy that you are allowed to do a homework late, okay, and turn it in. And it's just really annoying if you don't turn it in on time. If I had set the deadline today, then a couple of you or someone in one of the other classes would have turned it late, then you've had to come to me and say, can you open up and unlock the homework? And I've had to go through and do all that stuff, and that's just a big old mess. It's easier just to have the deadline, the official deadline, have that homework open, but us communicate to you, the deadline is today on Radical Review 1, 2, and 3. If you do not finish that, okay, then you can turn it in late. The maximum grade that you can get is a 70. Like I said, as you know, the school policy outlined that the first day. But here's the catch. We normally, I'm the one who enters grades for this class. I enter grades normally Friday afternoon or Saturday or Sunday, sometime over the weekend. Okay, so that means I'm going on to Alex and I'm clicking 3rd period, Radical Review 1, print, and then I go key it in, key it in, key it in. Radical Review 2, 3rd period, print. It prints out all those grades, okay? Now, and then I type that into the system. So let's say I'm gonna pick someone very unlikely, Preston. Preston does not do Radical Review 3, okay? Unlikely though that might be, right? Stuff happens, life gets in the way, and he's not able to finish that. However, like I said, it's still open. You can still work on it, okay? Maximum grade you get is a 70 in the grade book. Maximum grade you get on Alex is going to be 100, okay? So, but let's say that over the weekend, you know, it shows a 0 for what he's done. I print it off. I entered a 0 or an M for missing. And then next Monday or Tuesday, has a little bit of extra time. He takes care of that homework. It shows up there. And then he comes to me next Thursday or Friday and says, Mr. Goddard, I did that homework. Why isn't it reported in the grade book? And here's just the issue, okay? I don't know that he has gone and done that homework that I have entered in a 0 for. Does that make sense? So we have to have a way for Preston and the rest of you to communicate to me that you have done a homework late, but now I need to go in and log in and check the grade book, because I'll be honest with you, I am not going to every single weekend log in and look back at every single homework that we've ever done and compare that with every single actual record. You know what I mean? We just need a little note, and that's what we're going to have. We'll have it next week because it really hasn't been issued until now. But next to that other tray, we'll have a tray with a little piece of paper that says, I completed this homework, and I completed it late, but now it's done. Please go look it up and update my grade. And you'll just fill that out, and you put it in a box right next to there. And then at the end of the week, when I'm typing in grades, I'll also go through all those and be like, oh, Preston says he did Radical Review 3. There it is. He made 100 on it. That's awesome. Unfortunately, the max grade I can give him is a 70 because it was late. We're trying to communicate that deadlines have consequences, and we're good for that. So in fact, any grade that you make over a 70 will just be capped at a 70. It's a ceiling function for those of you that are familiar with the computer science terminology, okay? So it's not like I'm going to be taking 70% of your grade. It's anything higher than 70 is going to be capped at 70. I think that should do it. So the bottom line is, if you do something late, generate the piece of paper, generate the form, and turn that in. Otherwise, I'm not going to know. Okay? You might get lucky. Do it like Friday evening at like 5 or 6 o'clock. You the deadline I say is like 4 o'clock or whatever. You do it like 5, but I don't enter it in until like Saturday afternoon or Sunday. You might be able to sneak it in on that. But I'm not going to promise.
Do you mean done as in 100 or done as in, like, do we need to have full credit for it to be done, or is it just like?
No. What grade you want is up to you. I mean, you could.
Yeah, I didn't know if it was something like that.
Nah. Only if you're like super crazy high achiever student. All right. So. Nope. Don't have to do all of it. I recommend you try to do all of it. So. Okay. All right. So, looking back at yesterday, we have these two special right triangles. Okay. That we talked about. It's good for us to kind of get a big picture about what we're trying to do here. Okay. And what we're trying to do here, fundamentally, there's lots of ways you can say we're just trying to learn trig and stuff like that. But one way to sort of frame our whole entire conversation is ask this question. Question or a need, and basically it's this like, I want to find the sides or angles of a triangle with the fewest or in the fewest possible steps. That's not really a question, that's sort of like a task. Mr. Greenshore, would you mind logging that computer real quick so I can pull up the homework problems? I'll try to frame things as a story since that kind of, I feel like, helps students in different situations. Okay? So, maybe you're with George Washington surveying, the colonies, and you want to figure out how much land is here. And what you could do is you could, go to this point and then walk all the way over to this point and measure this, right? And then you could go here and walk all the way up here and measure this, so you end up with A and you end up with B. And then you could do area is 1/2 A times B, and you can find the area of this region, and you can figure out exactly how much land is there. That might be something helpful for you. But why bother? Why, that's a whole lot of walking, especially if maybe this is up, a hill, because then the next thing you're going to do is you're going to do the same thing over here, and then do the same thing over here. You see what I'm saying? It's like a whole lot of walking, especially if, this is what the land area that you're talking about. As everybody knows, any irregular shape, you can break it down into triangles. You know that, right? You just be like, you start breaking up into triangles. There. Break everything up into triangles. And yeah, you take any shape and break it up into triangles. Right? I mean, take a square and break it up into triangles. Take a hexagon, break it up into triangles. I don't know, I'll just do that. Yeah. If you break it up into triangles and then you can solve the triangle, then you can kind of figure out your problems, okay? And in this case, maybe you're concerned about finding the area. In order to find the area, you need to know the sides. And so all this sort of boils down to, how can I find the sides with the shortest possible steps? Does that make sense? Anyway, if I can find the shortest possible steps, then I can figure out the whole land of the area, or the area of the land, yada, yada, yada. So, the long way would be Pythagorean, walking and walking. The shorter way, the better way of figuring out these would be figure out one side, okay, and then figure out this angle, all right? I'll call this angle, can we go Greek? Theta. So you stand right here, and you get your little measuring device, and you have your buddy stand over here, with like a stick in his hand, for different reasons, I don't know, because it looks funny. and you're like, all right, I got you. I'm looking at you here, and then you take your measuring device and you swivel there over here to the mountain, and you say, oh, okay, this is 40 degrees from here to here. And then you just count how many steps it is to your friend, okay? Turns out that you just walked 100 feet, or maybe it was a mile or something, I don't know. And all you have to do is walk from here to here and measure this, and then hopefully, somewhere, somebody has created a very, very, very accurate triangle with a 40 degrees right there, okay? And knows the ratio of those sides, okay? So somebody else, knows the ratio. They've actually got a number here. I'll call this X and Y and Z. And somebody else has done all the hard work, so it's actually some number here. Because then you just go and say, oh, and somebody drawn a really, really accurate 40 degree, 40, 90, 50 triangle. Because if I can get that information from them, okay, then what I can do is I can say that my 100 over B ratio is equal to their X over their Y, which theirs is number, right? Because then if I have this, I've got the 100, I've got the X, I've got the Y, then using cross multiplication in butterfly, very quickly I can figure out what B is. Number. And then if I know B, then I can do 1/2 base times height, and I can figure out the area. I can even do Pythagorean theorem and find the perimeter, and I don't have to walk all the way over here, and I can very quickly spin around and tell my friend to go walk over here, and he'll write his numbers down, and eventually walk. And I can get multiple triangles done just by standing right here and going, what is from here to here? Hey, you walk and measure that distance. He measures. Hey, now you walk over here, and I'm going to measure here to here. Do y'all kind of start to see how this is helpful? And it's all about, I want to find the sides, and I want to find those angles with the fewest possible steps. Now, the angles is not difficult because we just know that all the angles in a triangle are equal to 180. 40 plus 90, we know this is 50. That's no big deal. The real hard part is to find those side lengths, okay? So, that was a strong motivating factor, okay? Now, I've kind of used George Washington, American history kind of example, okay? But this is 100 times even more so true with ships and sailing and trying to get from one location to another, okay? And they would use charts, and then they'd also use the stars, and they would use trigonometry. And if you wanted to be a navigator and be a ship on a ship, then you'd have to learn trigonometry. So that's sort of where a lot of this math arose. As it turns out, mathematicians kept dealing with this, and they started making graphs of this, and they found out that there's the similarity between there and the electromagnetic spectrum. And then they were able to do stuff with electronics, and then we're able to do things like have Wi-Fi and Bluetooth and stuff like that based on these. And we'll get to that eventually. But the example that I know you can understand is the George Washington sort of motivation. So, that being said, we talked that there were some people somewhere that measured these triangles really, really accurately, right? And they recorded those numbers. They said 40 degrees. If you have your X and Y or Z, we'll record for you actually what X over Z is. And they've got that number there. And then we will record what X over, or what Y over Z is. This over this. And we'll record what X over Y is. And they put this down in a journal, right? And they put it in, and then they did it for 40.1 degrees and 40.2 degrees. And also, we saw that trig table the other day, and then you could buy that, and that would be really helpful for you. Okay? And we also mentioned that rather than having this, because that might sort of get a little bit confusing, which one you're talking about, they came up with nicknames for these ratios, okay? And so next week, we are going to kind of use those and play the George Washington game and figure out how long this other side was, okay? But today, all I'm going to ask you to do is get familiar and super comfortable with these ratios and their nicknames and how they're used, okay? Just step by step, okay? So today, it's all about those nicknames. And here they are, one more time, along with their weird cousins. So, if I have an angle right there, we'll call it theta, on a right triangle. I'll always circle the angle and draw an arrow to the opposite leg, okay, or the opposite side, and I'm going to call that the opposite. Then we all know that the longest side right there is the hypotenuse. I see, by the way, that all of y'all are taking notes and kind of write down what I write down, even if it's kind of weird and scraggly, but that's fine. That's good. I appreciate that. And then we have a very interesting name for this side here, which is right next to or neighborly with this angle. Do y'all remember the word that we used? Adjacent. Adjacent. Right. So we kind of hinted at this on Tuesday, but now I'm actually giving you the formal, a formal lecture, as it were. Goodbye, George Washington. Okay. So the ratio of the opposite over hypotenuse is called the sine. So we would say sine of theta is the opposite over hypotenuse. This over this. The cosine of theta is the adjacent over the hypotenuse. I'm just going to abbreviate that ADJ and hypotenuse HYP. And then the tangent, which I'll abbreviate tan, of theta. That's, by the way, the Greek letter theta. Have y'all seen it in some of your other classes? Your Greek class, maybe? Ancient civilizations class? That's a joke. I know you're not Greek. Opposite over adjacent. I did sub one time at a high school that taught Latin. And I was the Latin, so. Man, I had to study real quick for that one. That was a long-term sub. They're like, ooh, lesson plans. And I'm like, okay. Like, I know some Greek and some Hebrew, but I don't know about Latin. So yeah, I had to make a quick study. The reason why they taught it, though, is because there's so much of our words are based on Latin root words. So the thought was, I guess someone at some point said, these kids need to know Latin so that then they can do well on their ACT. You know what? They did. So just as a reminder, so when we don't say sin, we say sine with a long I. We don't say cos, we say cosine, okay? Very few things get me angry. But one of them is by sinning in class, or cause, or tangent. Say the word tangent. Say the whole thing. All right? So, all right. And then we have their the weird cousins upside down. Oh yeah. All right. So this is we've got this other thing here called the cosecant. Okay. So the cosecant, actually, they're formally called the reciprocal. RECIPROCAL. The reciprocal trig ratios. Does anybody remember from Algebra 1 what reciprocal means? Technically, the opposite would mean the negation of. not the opposite.
The flip.
The flipped. Yeah, they're standing on their head. So it's kind of. So it's you could write it. I don't know if I'll write it on this. You could write it as 1 over sine, or you could write it as hypotenuse over opposite. It's just the reciprocal one. The denominator goes to the numerator goes to the denominator. And I will write that out. Cosecant. Oh, that handwriting doesn't really help out very much. C-O-S-E-C-A-N-T. Then we have the secant, which is 1 over the cosine. So that's the hypotenuse over adjacent. So we would say secant. Students always, if they're going to make a mistake on this, then they're going to make a mistake and match the cosecant with the cosine, and that is not correct. The cos do not belong together, okay? It's sine and cosecant, cosine and secant, and then tangent and cot. Not coat, it's just cotangent. You see cot, you say cotangent. That's 1 over tangent, or the adjacent over hypotenuse. Adjacent over opposite. All right, I'll cotangent. If you remember on your Alex knowledge checks, I am going to give you 1 page front and back. If you get to the point where you're solving some of these things, like on your 10 weekly topics, and think that they might be on your knowledge check, which they very well could be, then you might want to write them down. At some point, I'll give you a Trig chart that sort of summarizes all this stuff too. I'll give you a minute to digest all that. I think that's enough theory. So yeah, remember the knowledge checks are not over the homeworks per se. They're over the things that you've mastered on Alex. So you really only need to know this for the homework. And then if you mastered on your pie chart, then you need to know it as well. But by that point, you've done it on homework and you've done it on your pie chart. All right. Let's do one of these together, then I'll let you work as a table on 1 or 2 more here. All right, so here we go. It says right triangle has side lengths of 5, 12, and 13 as shown below. Use these lengths to find cosine A, tangent A, and sine A. We'll, I guess, do it in the order that they're interested in. So, cosine A. Pause now for station identification. Cosine A equals. Write it down if you don't have it memorized. Adjacent over hypotenuse equals. Label it if you can't do it off the top of your head. So we will circle angle A and draw an arrow, as always, to the opposite side. We will then label Following that same procedure, the hypotenuse, namely the longest side of the side across from the 90-degree angle, which would be the 13 in this case. And then the one that's left must be adjacent. And then we fill in the blanks. Adjacent is on the 12. So it's a 12 right there. I'm not sure what that is. Hypotenuse is 13. And you're done with the cosine. You don't need to write this as a decimal approximation. This is perfect as is, a fraction. Okay? Tangent, if you don't have it memorized, you write it down so that you do get it memorized. Opposite over adjacent. Someone call it to me. What's the opposite side? What's the adjacent side? 12. Okay. Just out of curiosity, do you all see that if this question had asked what is the tangent of B, did I get different answers? Yeah, you would. Because if it had asked cosine A, tangent A, sine of A, then, or sorry, cosine B, tangent B, sine of B, then I would have circled B, and my arrow would be pointing to another place, and that would be my opposite, and that would be my adjacent, my hypotenuse would be the same. But those other ones would be different. So it makes a difference whether or not you're talking about angle A or angle B. Okay? Because that's what the angle then determines which is your opposite and which is your adjacent. And we talked about that on Tuesday, so I'm not really thinking about that. And then y'all are already like on problem 5, but that's okay. Sine A is opposite over hypotenuse. So the opposite is 5, and the hypotenuse is 13. My goal is to make this as straightforward as possible so that I'm not skipping steps. I'm giving you some tools to be able to solve these even 3 days from now or possibly next Wednesday when you get around to taking care of the homework. I don't know. Maybe disappear if I can work fast enough. I'm going to let you as a table take care of 2, maybe 3. And I'll come around and start checking stuff. So I want you to be in agreement with the table. When you are in agreement as a table, then give me the sign. We get 3, 4, 5 all agreement. Ooh, good question.
I don't remember 4 minutes though.
No.
Yes. How would you solve that? So we need a piece, right?
You get
How would you find that piece?
one of them was low in the 20s.
It is.
Let's see what this is.
I was thinking about the square root.
Yeah, square root are involved. So let me frame the question this way. You have 2 sides of a right triangle. How would you find the 2 sides?
During the
No.
And the answer is find the side. Then you'll be able to play the game. Bailey, you were gone yesterday? 2 days ago. Yesterday was
Yeah.
a lecture day. What's that?
I looked up the video.
You did?
Yeah.
But I don't think I uploaded it until this morning.
Yeah, I watched it this morning.
You watched it? Oh my gosh. High five. But did you like it?
You could barely hear you, but
Oh my gosh. So I need to get mic'd?
yeah, it's because you can't hear anything.
Man, I would think with these walls and the floor you'd be able to hear everything. Sorry about that, other students watching this. Emma? Alright. Well, I will somehow talk louder. Alright. I need to see 2. Number 2. 15 over 8, 17. That's good. It says you can, but I don't want you. I don't want that. I don't want decimal approximations. I just want radical, even in radical form.
So you,
Let me-
it would be the square root of 140.
Yeah, that's fine. Yep, that's what it would be. Good at 2. Y'all agree on 2? Agree? 15 over 8. 15 or 17. Good. Good 3. So B over C, C over A, B over A. We're in good shape. Alright, back to you. 4. B over F. U over F.
Oh, yeah, I mean, I can do it in the square.
I did with the square root. It said no decimal approximation.
Yeah. The good question. Yeah, and we'll get that one. Who have I not checked? Trey, Dalton. Show me 2.
This is not guessing something, man. Because it's like everything is strategic. What is that as well?
Yeah, just fractions are fine. 15 over 8, 15 over 17.
And then what?
It's not possible.
I feel like
B over C, C over A,
No,
B over A.
no, so we have one thing you have when you like the way you ask me and you ask me what kind of stuff.
What? Yeah, it says it
Yep, I
that.
think we're good.
So now I know that you guys don't need a better hand that when I come.
Fractions fine. Yep, not a decimal approximation.
I missed my other pencil.
You know what that is?
Do what? Time to draw.
Alright, Travis, I haven't checked you all yet. Are we good on number 2? We good 15 over 17. Okay. So you got them in different order.
No, it's a.
So sine, 15 or 17.
Okay, that actually does
Cosine,
look like a
B
virus.
over tangent,
Bacteria phase.
Yep, looks good.
That's the Dino.
What about the next
that's
page?
type B.
Are you on agreement? Need y'all to talk.
I don't talk.
I know. Okay, that's a problem. No. So I'm okay with talking when I say it's a table. I want you to talk to table. So it's on homework. 15 over 17. How'd you figure the 17? Yep. It's crazy. Why does mine have 7? Oh well. Okay. Okay, let's see here. Number 5 asks for sine. Sine is of this angle, so opposite over hypotenuse, which is 15 over, oh my gosh, what's the problem here, class?
Uh-oh.
No.
You don't have a number.
What's wrong with this, class?
I don't have a
Oh,
number.
yeah.
We don't have it, there's nothing there. Okay, so how are we gonna find the hypotenuse when we have 2 legs? Pythagorean theorem. Those of you that did the Pythagorean theorem, what is the hypotenuse?
17.
17, so 15 over 17. Are we good? Okay. Now, look around, I did see some different situations here with number 6. So, it's the same kind of thing. They want us to find the cosine. So the cosine of theta is going to be 12, the adjacent, the adjacent, which is this thing right here, I don't know. I'm going to call it x, why not? So we need to figure out what x is. So here I'm going to go Pythagorean theorem, I'll actually work this one out. X squared plus 12 squared equals 13 squared. So x squared plus 144 equals 169. So x squared, am I right on this?
Yeah.
What's 169 minus 144, class?
25.
25? So you're telling me x is 5?
Yes.
Well, that's not difficult. Is
That
5
was the
over
point.
13? Is that it?
Yeah. Number 7 is more difficult.
Number 7 what?
Number 7 is more difficult.
Okay, that's what I want to do. Let's do number 7. Thank you. Alright, so I've got a 5 and a 4. Oh, I wish they were in a different order. There'd be a 3, 4, 5 triangle. I know that one by heart. But I don't know this one by heart. So this says tangent, secant, and sine. I'm gonna do this in reverse order just for fun. So sine of theta, let's circle that. Okay, so this is the opposite. That's the hypotenuse. I don't know what the hypotenuse is. I'll call it C, maybe, sort of like an ABC sort of situation. So I'll write 5 squared plus 4 squared equals C squared. So that's going to be 25 plus 16 equals C squared. So C squared, help me out, mathematicians here, 25 plus 16?
Something. 41.
41, okay. And then I'll take the square root of both sides. Can I simplify the square root of 41?
No. 41's prime.
41's prime. All right now. So that's it, square root of 41. So C equals square root of 41. I'm comfortable with radical side lengths, and you can be too. So sine is going to be 5 over the square root of 41. And according to my answer key, that is an acceptable answer.
Wait, you don't have to rationalize it?
Oh.
The radical in the denominator is seems to be an officially accepted Alex answer.
Oh, Alex is done.
It would have, oh, you definitely don't want to make it
You
decimal
would have to
because they say
rationalize it.
not decimal approximations, but if you're saying doing that, you don't have to rationalize it either, at least according to this documentation. Now, if we were to rationalize it, we would multiply it by the square root of 41 over the square root of 41, which would be 5 root 41 over 41, and 5 over 41 can't reduce because 41 is prime, so.
I wonder if so they just teach us that for 2 weeks and then throw it away.
Like I told you, as far as my research went, the only reason to have rational denominators is so it's easier to grade. For teachers way back when. I maybe missed that. Okay, so, okay, we'll do the secant because that one's kind of weird. Secant theta, I'm gonna have to refer to my board because I can never remember it. Opposite over adjacent. hypotenuse over adjacent. So I'll write it down here just to. So hypotenuse square root of 41 over adjacent 4. Done. So this homework, today's activity is really like it's really an intermediary step, okay? It's getting us completely comfortable with these ratios, okay? Like I said, next week we're going to apply this knowledge and use it to find out mystery sides, like I did that first day when I'm like, I'm gonna tell you what your other triangle side is, you know? And so that George Washington can go home at night, you know, and rest without having to walk, you know, an extra 200 miles. That's where we're going with all of this. But today, it's literally just become super familiar. If I say sine, you can be like, oh yeah, that's gonna be this side over that one. Or if I say cosine, you're like, okay, it's this over that. Or tangent, it's these over here, because this is literally like a 2-second part of a, you know, of a 1-minute problem. But we've got to become familiar with all these ratios and the sides. Was there a number 8?
Yeah.
Which is on the.
No, opposite.
Exact values, not decimal approximations. So did anybody get a number here for this other side using Pythagorean theorem?
Root 17.
Square root of 17.
That's a lot of
Square root of 17 is correct. So yeah. So in case anybody's curious what these values are, if you didn't want to check your work here, the sine is 8 over 9. The cotangent, root 17 over 8. And the cosecant is 9 over 8. I'm pretty confident. So I know y'all kind of saw some of these last year, and this is great. Today we talked about the 3 trig ratios and their, I don't know, gymnastic or